Imagine an asteroid the size of Washington, D.C. hurtling towards Earth. It's a terrifying thought, isn't it? This isn't just the stuff of science fiction or disaster movies. It's a scenario that scientists have studied extensively. The science behind such an event is both fascinating and horrifying. Picture this colossal rock, a celestial giant composed of rock and metal, traveling through the vast expanse of space. As it approaches Earth, it moves at an unimaginable speed, a silent harbinger of doom. It's a scenario straight out of a disaster movie, but the science behind it is very real. Scientists have long studied the potential impacts of such an event using computer models and historical data to understand the consequences. If such an asteroid were to strike Washington, D.C., the day would begin like any other. People would go about their daily routines, unaware of the impending disaster. But by the end of the day, the city would be unrecognizable, reduced to rubble and ash. As the asteroid enters Earth's atmosphere, it would be traveling at an incredible speed, its leading edge glowing white-hot from the friction. The heat generated would be so intense that it would light up the sky, creating a spectacle visible for miles around. The impact would be instant and merciless. The energy released upon collision would be equivalent to millions of tons of TNT, far surpassing the power of any human-made explosive. The energy released would dwarf the power of all nuclear weapons ever detonated combined. The shockwave would travel at supersonic speeds, flattening everything in its path. A blinding flash of light, visible for hundreds of miles, would be the first sign of catastrophe. This flash would be followed by a deafening roar as the shockwave and heat blast spread outwards. The city of Washington, D.C., along with its monuments and history, would be vaporized in less than a second. The sheer force of the impact would obliterate everything, leaving behind a barren wasteland. The immediate blast zone would extend for hundreds of miles, engulfing everything within it in a sea of fire. Buildings, trees, and even the ground itself would be scorched beyond recognition. The aftermath would be a scene of unimaginable destruction, a stark reminder of the power of the cosmos. At the moment of impact, the asteroid would create a crater miles wide, a gaping wound on the Earth's surface that would be visible from space. The crater would be hundreds of feet deep, a testament to the sheer force of the collision. Within this crater, the temperature would reach millions of degrees Celsius, hotter than the surface of the sun. Everything within this zone, buildings, people, trees, would be instantly vaporized, leaving behind nothing but a barren, lifeless expanse. The intense heat would melt the ground, turning solid rock into molten lava, creating rivers of fire that would flow from the impact site. The shockwave from the impact would radiate outwards at supersonic speeds, flattening everything in its path. Buildings would crumble, bridges would collapse, and trees would be uprooted like twigs. Unable to withstand the immense force, the air itself would superheat, igniting wildfires that would rage across the landscape, consuming everything in their path. Those unfortunate enough to be within a certain radius of the impact would be killed instantly, vaporized by the heat or crushed by the shockwave. The devastation would be total, leaving no survivors in the immediate vicinity. In the aftermath, the landscape would be unrecognizable, a smoldering ruin where life once thrived. The impact would send shockwaves through the planet, altering the course of history forever. The devastation wouldn't be confined to Washington, D.C. The shockwaves from the impact would travel thousands of miles, causing widespread earthquakes and volcanic eruptions. Coastal areas would be inundated by massive tsunamis, generated by the seismic shockwaves traveling through the ocean. The east coast of the United States, in particular, would be devastated. Major cities like New York City, Philadelphia, and Boston would experience catastrophic damage from the combined effects of earthquakes, tsunamis, and fires. Millions of people would be displaced, injured, or killed. The long-term consequences of such an impact would be even more severe. The massive amount of dust and debris ejected into the atmosphere would block out the sun, plunging the Earth into a state of perpetual twilight. This impact winter could last for months or even years, disrupting agriculture and causing widespread famine. The impact would also release massive amounts of greenhouse gases into the atmosphere, leading to rapid and unpredictable climate change. Global temperatures could fluctuate wildly, causing extreme weather events such as hurricanes, floods, and droughts. Section 5. Dust and darkness. The nuclear winter scenario. One of the most concerning long-term effects of the impact would be the potential for a nuclear winter. The dust and debris ejected into the atmosphere would block sunlight, leading to a significant drop in global temperatures. This cooling effect, combined with the widespread fires and disruption to the Earth's ecosystems, could trigger a chain reaction of environmental disasters. The planet's delicate balance would be thrown into chaos, with unpredictable and potentially devastating consequences for all life on Earth. Section 6. Picking up the pieces, the challenge of survival. In the aftermath of such a catastrophic event, the challenges facing humanity would be immense. The immediate priority would be to provide aid and shelter to the millions of survivors. With infrastructure destroyed and resources scarce, this would be a Herculean task. The long-term challenge would be to rebuild civilization in a world forever altered. Food production would be severely disrupted, clean water would be scarce, and the threat of disease would be ever present. Humanity's resilience and adaptability would be put to the ultimate test. Section 7. Rebuilding hope, the long road to recovery. Despite the unimaginable scale of the disaster, humanity would not be defeated. Throughout history, we have demonstrated an indomitable spirit and an ability to overcome adversity. The rebuilding process would be long and arduous, but it would also be a testament to our collective will to survive. Scientists and engineers would play a crucial role in this new world, developing technologies to purify water, grow food in challenging conditions, and generate energy from renewable sources. The lessons learned from this catastrophe would drive innovation and lead to a more sustainable and resilient future. Section 8. Lessons learned. The importance of planetary defense. The impact of a giant asteroid on Washington, D.C. would be a stark reminder of our vulnerability in the cosmos. It would underscore the importance of investing in planetary defense systems, such as early detection networks and asteroid deflection technologies. By developing the capability to identify and deflect potentially hazardous asteroids, we can mitigate the risk of such a catastrophic event ever happening again. This is not just a matter of scientific curiosity, but a fundamental issue of human survival. Section 9. Our future among the stars. A call to action. The universe is a vast and awe-inspiring place, full of wonder and danger in equal measure. It stretches beyond our imagination, filled with countless stars, planets, and mysteries waiting to be uncovered. Each twinkling star represents a potential new world, a new opportunity for discovery and understanding. But with these opportunities come significant risks and challenges that we must be ready to face. As we venture further out into space, we must be prepared for the challenges that await us. The harsh environment of space, with its extreme temperatures and radiation, requires us to develop advanced technologies and strategies for survival. Our astronauts, the brave pioneers of this new frontier, are constantly pushing the boundaries of what is possible, conducting experiments and gathering data that will pave the way for future missions. The impact scenario, while hypothetical, serves as a stark reminder of the importance of understanding our place in the cosmos. It highlights the need for vigilance and preparedness. By studying asteroids and other celestial bodies, we can develop strategies to protect our planet from potential threats. This knowledge not only safeguards our home, but also enhances our understanding of the universe. By investing in science, education, and space exploration, we can ensure that humanity is ready to face the challenges of the future, both on Earth and beyond. Our scientists and researchers are the backbone of this endeavor, tirelessly working to unlock the secrets of the universe. Education plays a crucial role in inspiring the next generation of explorers and innovators, equipping them with the knowledge and skills needed to continue our journey into the stars. The survival of our species depends on our ability to learn from the past, adapt to the present, and prepare for the future. Historical space missions have taught us valuable lessons, and the rapid advancement of technology continues to open new doors. As we look to the future, we must embrace innovation and be willing to adapt to new ways of living and working, ensuring that we are always ready for the next great leap. Let us rise to the challenge and secure a brighter future for generations to come. Together we can achieve greatness, exploring the far reaches of space and unlocking the mysteries of the cosmos. By fostering a spirit of curiosity and determination, we can inspire future generations to dream big and reach for the stars. The journey ahead is long and filled with obstacles, but with unity and perseverance, we can overcome any challenge and create a legacy that will endure for millennia.